Welcome to Data Engineers Lunch number 108. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. Today we will discuss what is a what is a data lakehouse platform with Alex Merced. He will discuss the fundamentals of a data lakehouse platform, focusing on architecture, benefits, and the crucial role of Dremio in facilitating this modern approach to data management. The co-organizers for this event are Rahul and myself. You can reach out to me at nicholasbrackley@anon.us for more information about Data Engineers Lunch, our sister lunch, Cassandra Lunch, or you can reach out to us at marketing@anon.us. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the data engineering community, drop an email again to me or to our marketing email. If you want to give a talk, please reach out to us here for either this lunch, Data Engineers Lunch, or our sister lunch, Cassandra Lunch. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data, and you can find out more about all the various groups and events at datacommunitydc.org. At Data Engineers Lunch, we cover everything from the ingress and egress of data and absolutely everything in between. We cover databases, ETL, data wrangling, data lakehouses, and all of the tools and processes in the data engineering world. If there's anyone that would like to say hi, what brought you here, or what you hope to get out of this, please drop something in the YouTube chat. Don't forget to like and subscribe, as well as turn on that notification bell so that you can get notified every time we post a video or go live. Few rules. This is a community, so please, if you have a question, ask it. Alex is generally cool with me asking him questions. We'll usually address those at the end. Always be polite and courteous to others and share what you know. Again, this is a community. We want to know what you're an expert in as well. Here at Anon, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. Data engineering is absolutely our bread and butter. We are also entering the LLM and generative AI space. We did a pretty interesting Cassandra lunch last week, and we have another one coming up talking about fine-tuning an LLM for data engineering purpose. Thanks to our sponsors, DataStax, George Washington University, and all of our institutional and organizational sponsors. If anybody has any job offers, you're looking for a job, please drop links in the chat. And if anybody has any meetups, hackathons, classes, or conferences that you would like to promote, please drop those links as well. So this is a series of our events here. On Mondays, we host Data Engineers Lunch. On Thursdays, we host Cassandra Lunch. And on Wednesdays, we host no-code data and AI platforms. That one's a little later in the day, but generally these are talks done by our CEO, Rahul, and are pretty interesting. Please check out our runbooks. There are 17 that are published and available at our website. I'll post the link in a moment. And with that, I will say thank you to Alex for being here. And I'm really looking forward to the talk. Please take it away.
Hey everybody, this is me, Alex, here once again at Anon's Data Engineers Lunch. Always a pleasure. And today I want to bring you guys a great presentation called What is a Data Lakehouse Platform? Basically, the bottom line is, over the years, the conversation was whether to lakehouse or not. But I think most people nowadays are on the bandwagon that lakehouse is a good idea. The question is, how do you tie all those pieces together? And that's what data lakehouse platforms are going to do. They're going to make our life a lot easier when we want to execute that data lakehouse strategy. So if you want to download all the slides from today's event, this link will take you to a shared folder where I have links to all my public presentations. So you can download the slides. So if you want to refer to any bits and bobs here. Okay, so I'll leave that up there for like another 10 seconds for anyone who wants to snap a quick photo. And Also here, I'm one of the co-authors of Apache Iceberg, the Definitive Guide, which is a book, an upcoming book from O'Reilly that'll be published within the next month or so. I think early May should be the release date. So you can scan that QR code though, and you can get yourself an early release version of the book before the complete book drops early May. So definitely scan that QR code, get yourself an early copy so you can start learning all about that Apache Iceberg Lakehouse now. A couple more announcements. Subsurface is our Lakehouse conference. So Dremio, we put on this Data Lakehouse conference every year. We have speakers from all across the industry talking about different Data Lakehouse topics, like how do you ingest data into Lakehouse? How do you implement a Data Lakehouse? How do you do data ops on the Lakehouse? Lots of talks on Apache Iceberg, all sorts of really great topics. So do make sure to not miss it and sign up. It's free. It's going to be virtual. Also, there's going to be a live portion that's going to be done in New York City. So if you're in the New York City area, that's going to be a really cool event with some really cool surprises. But either way, whether you watch it online or you come visit us in person, the event is free and you can join over there at dremio.com/subsurface. So do sign up. That way you don't miss any of the announcements along the way and miss some what will be some really amazing talks this year. And of course, there's me. I'm Alex. I'm a developer advocate here at Dremio. And I spend a lot of time talking about the Lakehouse, Iceberg, Apache Arrow, whatnot. As you know, I'm one of the co-authors of Apache Iceberg, the Definitive Guide, but I'm also the host of several different data podcasts, including Gnarly Data Waves, In the Grand Scheme of Things, Data Nation, Select Star from Data Lake, which you can subscribe to on iTunes and Spotify. You can find all the links to that, my socials, everything, my Substack, all over there at bio.alexmerced.com/data. Okay, so constantly putting out content. There's a lot to say in the data space. It's a very exciting time. So do check it out. And with no further ado, let's begin. And first thing we want to talk about is what is a data lakehouse? Because if there's a data lakehouse platform, well, it's a platform for data lakehouses. But what's a data lakehouse? Well, to understand that, we need to understand what came before data lakehouses. So traditionally, when we did a lot of our data work, we would work with traditional systems like databases and data warehouses. And the beauty of these software systems is that they would take care of a lot of the things we'd have to think about if you wanted to really have solid data management. Okay, they would figure out how to store the data. Okay, so I don't have to really think about how Postgres stores the data underneath. It just does it. Okay, I don't have to think about how a data warehouse stores the data under the hood. It just does it. I just, run my create and inserts and update statements, and the storage of the data is just kind of handled under the hood. Now, all that data that's stored, how do we recognize table A from table B from table C? Well, that's with the table format. So every database, every data warehouse has some sort of way that it recognizes an individual table from the data that is stored, and that's abstracted away. Now, how do we know what tables are available? So how do I know that table A, table B, and table C are all available in the system? Well, a catalog. Okay, so every data system, whether it's a database or data warehouse, abstracts away this catalog that allows us to be aware of the variety of tables we have available to us in the system. And on top of it, that's all well and good. But the reason I have these systems is because I want to run queries. So I need systems that parse my SQL, that then take that SQL and create a query plan, and then execute that query plan. Okay, and that's all sort of abstracted away as well. So all these things are part of that database or data warehouse software. But as an end user, I just write SQL and I interact with it and run my analytics, and I don't have to really kind of trouble myself with these things. And again, generally one of the main differences is that oftentimes when we're working with databases, we're working with OLTP or transactional systems that prefer to have the data stored in rows. While when we're working with data warehouses, we're often working with analytical systems that typically store the data as columns. Okay, but at the end of the day, they're both abstracting all these layers of stuff. Okay, and it's just kind of all in a box. The only downside is, since all that stuff is abstracted away, the data has to be in the box. Okay, it has to be in the database. It has to be in the data warehouse. And if I want to use a different data warehouse's features and tools, they can't communicate with the data that I have in my first data warehouse. So then I have to migrate the data from one system to the next, resulting in lots of copies of data, resulting in having to figure out how to do these migrations and the time it takes to plan and execute these migrations before I even start running analytics. So there's this lost time. And also the deal with storing large amounts of data and the cost of that in a lot of these systems, we run into the scaling issue into modern times because now we're dealing with much more data that's being generated faster than ever before, and we need to put that to use faster than ever before. So having these sort of overly abstracted systems are becoming bottlenecks in that growing scale. So what happened is that there is another system that we have. We oftentimes would have something called a data lake, which was really mainly a storage system. Basically, we just use some sort of storage layer, which could be like a Hadoop cluster or an Amazon S3 object storage or ADLS object storage. It's just some sort of storage layer, which would store files like Parquet files, CSV files, JSON files with our data in it. And then we'd have separate tools, separate processing engines like Dremio or AWS Athena that would be able to run queries against that storage. And that's fine. That was good for ad hoc analytics and doing some analytics off the data lake. But it wasn't like a data warehouse. It wasn't like a database. I couldn't suddenly really do a lot of like updates and deletes that have the same kind of guarantees that I do in a data warehouse. It wasn't as fast. There was just a lot of things sort of missing. But if we can introduce the remaining pieces that databases and data warehouses have, well, then we can turn that data lake into a data warehouse. And that's where we get the idea of a data lakehouse. We take that storage layer, we take that compute layer, but then we inject what was missing in between, a much easier way to recognize what tables you have in your data lake. So now I can say, hey, these 1,000 Parquet files, that's table A. And I have metadata to figure out, hey, when I have a particular query, do I really need to scan all 1,000 Parquet files? I can do file pruning and do much more sophisticated query planning using the metadata in that table format about that specific table. I could use a catalog, some sort of catalog that allows me to track all the different tables. So that way I can take that group of tables and be able to recognize them with all my favorite tools that can support my table format. Okay, so a table format like Apache Iceberg and a catalog like Nessie, which is another open source project that allows you to catalog your Iceberg tables. And with all this, you now have an experience that can be very, very much like a data warehouse. Like I could log into Dremio, I can run SQL queries, run updates, inserts, deletes, okay, on data, and it's stored in my data lake, but it's recognized as a normal database table because of Apache Iceberg, and I'm able to see all the tables because of using a catalog like Nessie. That's all fun and good, but I still have to kind of piece all these things together. Like how do I might have to go, deploy the Nessie catalog and run that service and manage that service. Okay, I'm going to have to go back and take those Apache Iceberg tables and make sure I do regular maintenance on them to do like compact data files, expire snapshots. So that's a lot of work. Okay, and it's like that's work I didn't have to deal with a data warehouse or a data lake. Wouldn't it be nice if I could get that ease of use to have all that stuff abstracted away with me, but still keep the flexibility, still keep the sort of open infrastructure, so I don't have to, if different tools want to read my data, they can read my data without me having to do those migrations, allowing me to kind of get to all the work I need to get done faster and deliver that data where it needs to be faster at a much lower cost. And that's why you need a data lakehouse platform, something that kind of ties everything together, basically smooths those edges of everything sort of being sort of separate and modular and make it feel more cohesive. Okay, and that's what a data lakehouse platform does. It just takes all those pieces, gives you a nice wrapper around it, so that way it feels like a traditional system without the lock-in, without the coupling of traditional systems. So when we take a look at a data lakehouse platform, how should it work? It should probably connect to your data anywhere. Okay, so it should connect to your data lake because it's a data lakehouse, right? So it should be able to connect to your storage, which could be object storage. Okay, could be on-prem storage. You might be using ADLS, S3, Google Cloud Storage, and it should be able to recognize the table format that your data is stored in, a format like Apache Iceberg. Okay, so a data lakehouse should be able to connect to your data lake and recognize your data. Okay, that is what we would expect, number one. Okay, basically, it should connect to my data lake that already has my data and pretty much recognize it like in the same way that I can just turn on a database and know what tables and what data I have available. But at the end of the day, not all of our data is going to be on the data lake. there's going to be this like long tail data. I always think of it like an 80-20 rule, that probably 80% of your data should be in your data lake, data lakehouse, but you're going to have this 20% of data in other systems. It might be in Snowflake because you're using the Snowflake data market. It might be on your S3 because you're using the or other systems within AWS because you're using AWS's data sharing marketplace. You might have it in other databases because they're odds and ends that aren't worth moving into the data lake, that you're just using to do a few different, to enrich a few different data sets here and there. So a data lakehouse platform shouldn't make you have to move all of your data to the data lake. It should allow you to reach that additional 20% of data and give you unified analytics and allow you to access the data you have in your relational databases, in your NoSQL databases like Mongo, Snowflake, for the same reasons that I just mentioned. You just have these other bits of data that aren't worth the move. They're fine where they're at, but you need them to curate the data sets your end users need. Okay? And that unified analytics not only allows you to connect to all this data, but allows you to curate that data into a semantic layer. So that way it's much easier for your end users to know what data sets they have available to them. That way they know sort of how they're organized, can actually read documentation of the data, can have that data governed. So that way they only can access the data that they're supposed to access and the parts of that data they're supposed to access, because they have role-based access controls, column-based access controls, row-based access controls. So all of this is going to provide this unified analytics layer that's required for a data lakehouse platform, for like a platform that's really going to just make your life easier, because you can just run your lakehouse really from one place, but again, still retain that flexibility, because your data lake is still going to have those iceberg tables, your catalog is still open, and you can connect to it with other tools. Okay. A good data lakehouse platform should allow you to query that data. Okay. Not only query your data lake, but be able to query all those other data sources that you have connected to your data lakehouse platform. Be able to federate those queries and be able to federate those queries to cloud and on-prem systems. So that way, if you have a footprint of on-prem data for security, regulatory reasons, or just legacy hardware, you are able to access that data, okay, and be able to enrich it with the data you may have in the cloud, which either may be other data that you have in the cloud because it's your data, or maybe data you've purchased to enrich your data, as I mentioned in the past. And you want to be able to query that data, and you want to be able to query that data fast. So you want an engine that already has high performance built into this data lakehouse platform, along with acceleration features that can push you even further. Okay, so that's the SQL query engine. So right now, a good data lakehouse platform should be able to unify your data. It should be able to provide you an engine to query that data, and it should provide you a way to manage that data. So instead of me having to constantly, be running my own manual compaction jobs and expiring snapshots, doing all this maintenance work I wouldn't have to do in a data warehouse, a good data lakehouse platform would do that work for me. So that way it does feel like a data warehouse where it just works. But a good data lakehouse platform should push it even further, not just make it feel like a data warehouse, but go beyond the data warehouse with cutting edge patterns for data ops, such as like catalog versioning, being able to create zero copy environments by branching your catalog, being able to execute multi-table transactions because you can isolate data on a branch. And that's where a tool like Nessie comes in. But again, Nessie was something you would normally have to deploy and manage yourself. A good lakehouse platform should be able to wrap Nessie in there and manage it for you, and give you a great form of being able to manage Nessie catalogs for tracking your iceberg tables. So you get those Git-like features around your catalog without all the work. You can just use them to enhance your data integration, your data experimentation, development, and so forth. And also use it for disaster recovery because you can roll back your catalog. So all these pieces are part of a good data lakehouse platform: the ability to unify your data, the ability to query that data, and the ability to have that data managed all from your data lake, but again, having it feel like it just works. Now, the thing is that your end users need to be able to access that data. So a good data lakehouse platform should be able to allow the users, the analysts, to be able to access that data through all the interfaces that they're used to accessing that data. ODBC, JDBC, which is the underlying tool that most like BI dashboard tools are going to connect to data sources with, through a REST API, especially when you're trying to automate different sort of activities, such as like user management and acceleration management of your Lakehouse platform. Having a REST API for you to be able to send commands and manage your data Lakehouse platform in a programmatic way. Apache Aeroflight, which is an even faster way to get data from your analytical systems, part of the Apache Aero project. So being able to have an Apache Aeroflight interface allows you to pull that data even faster. And that way you can pull that data into your use cases like data science, dashboards, applications. Okay, so I should be able to pull all that data in easily and quickly using these interfaces. So that way, whatever data I have unified, so I can take all my data, unify it, and be able to deliver it wherever you need it. Get all your data everywhere and deliver it anywhere. And Dremio is a platform that actually ties all that together. It has all the markers of what you need in a unified Lakehouse platform for self-service analytics. And not only does it have all these markers, but it has a flexible deployment model where you can either deploy it in a self-managed way. So you can self-manage it in case you need to have it located in a private cloud or you need to run it on-prem. You can self-manage a Dremio and you can easily deploy it using our K8s Helm chart. So you can just use Kubernetes Helm to easily deploy, and basically there's documentation so that way you know which settings you want to change if you don't want to use the default settings in our Helm chart. Which also comes with the ability to do auto scaling. So basically the K8s Helm chart has the ability to scale up the number of nodes you have based on certain factors. So that way you always have the compute you need and not the compute you don't. But there's also a cloud enterprise edition of Dremio where you can just get started by signing up. You just sign up over there at dremio.com, connect your AWS cloud, connect your Azure cloud, and you're off to the races. And the cool thing about that is, again, you have even more robust auto scaling features there because you can choose how many different engines you want running, what size those engines, using like t-shirt sizing, extra large engines. So that way you only use the compute you need and only for when you need it. And you can actually route queries to different engines. So you can say, hey, these high priority queries can go to the extra large engine. These lower priority queries can go to the smaller engine. So that way you're not spending more money than you need to on queries that don't justify those costs. So you have really, really solid sort of cost management on top of the cost savings that you're already having on not having to duplicate your data across multiple systems, on having faster queries because Dremio is very fast with its reflections feature, which is with its being built head to toe using Apache Aero for processing. It's really fast, giving you fast queries that are going to reduce your costs. And it also has something called the columnar cloud cache, which will reduce a lot of your network fees with your object storage, which acts as like a caching layer for assets on object storage. So overall, it's going to lower your costs and increase the time that it takes to get the data where you need it. Okay, so that's what it takes to be a data lakehouse platform. And at least at the moment, Dremio is the only platform that I'm aware that checks all these boxes of being a data lakehouse platform that truly unifies all the pieces you need in one platform to have a data lakehouse and execute a data lakehouse with ease. Now, right now you're just hearing me tell you that, hey, Dremio is cool, but how can you really see it and experience it for yourself? Get hands-on. And with that, I got a couple cool tools for you. So this QR code right over here on the left is an exercise that you can do with Docker. So it requires you to spin up no cloud infrastructure. You can just do it all from your laptop. You use Docker Compose to spin up a Nessie server, Dremio, and Minio for storage. And you can actually experience the Dremio platform, run queries, create some iceberg tables, and see how easy it actually is to execute lakehouse patterns with ease. And if you find that to be a worthwhile experience and want to explore using Dremio in production, okay, this QR code here on the right, so the one on the left is the tutorial, the one on the right is going to be the one that allows you to go to our Get Started page to either deploy through the self-managed through the K8s Helm chart or through Dremio Cloud. And again, the starting price is free, okay? It's free to go deploy Dremio with the K8s Helm chart. There's no licensing fees. It's free to sign up for Dremio Cloud. There's no monthly charges with Dremio. There are your infrastructure fees with your cloud provider, but that's not through us. And then, when you want the additional enterprise features, then you can always upgrade, but you can get started for free and getting a lot of that benefit by just using Dremio and really helping deliver data from everywhere to anywhere using the Dremio Lakehouse platform today. But again, there's a lot more I can say about the Data Lakehouse. And a good place to learn more about the Data Lakehouse and just the different ways you can do different Lakehouse, the different components you can use, is to head over to the Subsurface Data Lakehouse Conference, which you can register at dremio.com/subsurface. Again, that's going to be May 2nd and 3rd here in 2024. If you're watching this at a future date, we'll always do another Subsurface conference, so still go to dremio.com/subsurface so you know about the next one. But do sign up for 2024 because it's going to be very exciting. I'm aware of the talks we have there, and there's some really good ones. Actually, the talks are already listed on the website, so you can see if there's anything that kind of catches your eye. And again, we're going to have that physical location in New York, which is going to be a good time. Okay, but with that, that wraps up this presentation. So I'm going to open it up to any questions that might be on any of the places that people are watching, and we'll go there.
Yeah, so I had one. In your list of data sources, you mentioned S3 and a variety of other data sources. I was wondering if there has been any direct integration with DigitalOcean, like DigitalOcean Spaces. It's S3 compatible, so it's likely you could use it that way.
Yes, if it's S3 compatible, you can use it with Dremio. So like Minio, Pure Storage, VAS, NetApp. So I imagine even DigitalOcean, if they're S3 compatible, will work just fine with Dremio.
Cool. Rahul wants to know, how do you think this compares to a service like Databricks?
It's sort of a different setup, but and then oftentimes there are people who use Dremio with Databricks, because oftentimes like Databricks is a much more AI ML focus. So basically, the core of Databricks is essentially managed Spark. So they're essentially giving you these compute clusters that run Spark for you, so that way you don't have to manage clusters that run Spark for you, and you can do all your sort of ETL, AI ML work through those clusters. And then they've since created like sort of their own proprietary version of Spark, rewritten, I think it was in C, called Photon, and you can spin up clusters of that. But really, they're providing you that more place to do these environments to do more imperative code. So either whether it's Python, Scala, not as SQL focused. So it's definitely more for like a technical audience. They do have Databricks SQL, but oftentimes if people really like sort of like that Python Scala type environment, they still have needs for like dashboards, and oftentimes they'll find that Dremio is just a good place to kind of execute those dashboards, because Dremio can allow them to take those Delta Lake tables that they have on their data lake and then enrich them with data they have from other sources, because Dremio can federate the queries, and Dremio can also read Delta Lake. So if you have data, again, let's say you have a Snowflake, and this is actually something we see with several customers where they have Snowflake and Databricks, and they need to unify that data, and then Dremio becomes the platform they use to very efficiently and low cost unify that data for dashboards. And then oftentimes they'll even offload other queries, because they'll realize like, hey, there's other queries that I'm doing on Databricks or I'm doing on Snowflake that are just much cheaper to do on Dremio. And then, the stuff I just really need Snowflake for, I just really need Databricks for, that really leverages like their specific features, I'll keep there. But for a lot of the queries for my dashboards, honestly, they're working right here real good with Dremio, so I can do it there much cheaper. And again, it's a really oftentimes the cost of setting up Dremio is heavily outweighed by the savings you get when you offload a few key workloads from those systems, because they're oftentimes a bit more expensive to run and to use, and a bit more technical. So oftentimes a data engineer can do a lot of the work they need to do to provide that data to the data users much easier in Dremio, because it's so SQL focused that even the data analyst can do a lot of that last mile ETL work. So if they need an extra column, they need to quickly do a join and create a view that's a result of a join, a lot of those things they can do pretty easily themselves, straight from Dremio, which really frees up the data engineer of a lot of work, so they can focus on integrating new data systems.
Rahul wanted to comment on that and say that they also push their Delta Lake product hard, the bronze, silver, and gold tables.
Yeah, and I mean the issue with like sort of the medallion architecture, depending on how you execute it, results in more copies of data, because you're having your bronze, silver, gold. So you just created like 3 layers of copies of your data. You can do a medallion signature on the semantic layer with Dremio, but you do it virtually, so there is no duplication of data. So people do do their modeling different ways on Dremio. So some people do like a medallion a setup. Some people do like a snowflake schema on Dremio. Like at the end of the day, you land your raw data. Your raw data is in the lakehouse, and then you model it virtually from there. And then the reflections will come in to help you accelerate anywhere that's needed, where it's needed. But in that way, you're not duplicating your data as much and still getting that performance. And then also, since you're reduce, it also reduces a lot of the compute you're doing because you're not running all that compute to create all these copies. So that's another way where Dremio saves you a lot of money.
That makes a lot of sense in terms of where the savings is coming in, both in terms of the lack of duplication and the lack of time to actually duplicate the data.
Yes.
So a couple more questions and comments in here. Anne wanted to say this is a very informative session.
Thank you.
And then we had a question from Mike Jadu. And your discussion here makes me think the answer is probably yes. But the question is Dremio more focused on dashboards?
No. It's like, yes, I would say like it's a very popular use case for Dremio. It's a place where I think Dremio fits very, very well. So basically, oftentimes it's not so much that Dremio is focused on dashboards, it's just that generally that's the low-hanging fruit when people first try out Dremio, where they see the most immediate value and they see savings and improvement of their current situation, like most immediately, is going to be with the dashboards because it's going to be really you just plug the data in, deliver where it needs to go. But Dremio also, we're really focused on trying to give you a holistic data lakehouse solution because you can still do AI/ML using the data from Dremio. You can just connect with Aeroflight, pull it into your favorite notebook environment like a Hex or a Deep Note, and do AI/ML work. It's just the dashboards oftentimes are very plug and play. So oftentimes this is the first stop when using Dremio, and then people expand their footprints once they see the value, the savings, and the performance that they experience with Dremio. So I usually would say yes, dashboards are a good place to start. So if you have a dashboard that's just not performing the way you like, that's a great place to try out Dremio and actually see it and see the proof in the pudding. But there's a lot of places where Dremio can really improve your data stores. We've been used heavily for like data migrations, where people are migrating from on-prem to cloud. So they'll connect both their on-prem and their target cloud data lakehouse to Dremio. And that way, all their users just have one interface with the data, and they don't have to think about where the data is located, making it really much easier for the engineers to move the data because they're not really disrupting the workflow of the users because you're federating, because of Dremio's federation features. Other places are like data mesh because Dremio has a lot of good collaboration features. So you can actually really designate spaces for different domains to work, and they can connect their data sources. So they don't all have to store the data in the same place, and they can curate their data products independently, document them, govern them separately. We're used a lot for like data applications since we have like the REST API. A lot of people build applications on top of Dremio to interface with partners. So there's a lot of different use cases, but again, oftentimes dashboards is one of the first stops that people first get introduced to Dremio with.
Thank you. So that is all the questions we had. I do want to remind everybody that Alex has another talk scheduled next month. I've been really looking forward to this one. The topic is setting up a data lakehouse on your laptop. Do you have anything you want to say about that before we sign off here?
Yeah. So actually next month we'll do that. And actually that one will be a hands-on workshop. So basically, if you want to participate in that workshop, make sure you have your laptop, which if you're watching me, I'm sure you do. And then also make sure you have Docker installed. So we'll all together be able to kind of spin up that Docker Compose image I talked about earlier, and be able to actually like experience Dremio firsthand on our laptops and actually kind of see how that lakehouse feels and kind of talk a little bit about the technical things that are kind of going on under the hood as we try it out and explore it a little bit more in depth. So that'll be next month's adventure and I guess that would be at the end of April.
That's right. And I believe if you are following Data Wranglers DC on Meetup, you can already see that event and get signed up. So, Alex, thank you for another great talk. And thank you everyone for attending. We'll be back. I believe we have one scheduled in 2 weeks. And then there is also a Cassandra lunch scheduled for this Thursday, the second in a series on fine-tuning LLMs. So, Alex, again, thank you, and we'll see you next time.
See you guys next time. Thank you. It's always a
Bye,
pleasure.
everybody.
Bye.
Okay, the stream is done.